Hello everyone, welcome back to our Generative AI series. In the previous lecture, we understood the core components of the LangChain and how these components work together in a complete workflow. Now it's time to move from theory to the practical part. Now in today's session, we will start implementing LangChain in our resume analysis project and see how the concepts we learned earlier are applied in a real world applications. By the end of this lecture, our project will have LangChain concepts integrated into its workflow. Instead of manually, we'll be handling the prompts or calling the LLM or any model interaction. So in place of that, we are going to use the LangChain components. So without any further delay, let's get started with the implementation. So for that, we need to remove from our previous previous implementation lecture, we have to remove this v.venv folder, and we are going to create a new virtual environment for us. So now we'll have a new virtual environment. We'll just run this command for virtual environment python -m venv.venv command, and then we'll activate the virtual environment. After activating it, we are going to upgrade our pip. So using this command we can upgrade the pip. So we'll be going to update the latest version of the pip here. Okay, and we after that we have to create a requirement.txt file. So what this will do is requirement.txt file will write all the commands. So manually will not go and download all the dependencies. What we'll do is we'll write it on the requirement.txt file, and then for installation we need to run the pip install -r requirements.txt command. So in this file we'll be having all the dependencies which we want to download in our virtual environments. So we are going to run this command to install all that dependencies in one shot. Okay, so what we are going to write inside that particular file, we'll see. After running this command, we'll go and we'll do the pip list, and we'll see how many dependencies we installed, whether that is got installed or not in our system. So in the requirement file, these dependencies we'll have, and we'll see what is the meaning of these dependencies one by one. And we are not mentioning any version number. So whatever the version number is needed, it will automatically installed from the requirement.txt file. We are not manually mentioning it, but in backend it will install the required dependencies for us. So for these dependencies we are not going to get into the details, we'll just see it in a high level. Fast API is a REST API framework which builds the backend APIs, which are helping us to build the backend APIs. Then UVCon, this is for runs Fast API app server. So this is using this command we'll be able to run the server. Then python.env, this is going to load the environment file for us. So we already know we are mentioning the .env file where our secret keys will be there. So python.env file will load that environment file, help us to read that data. Then pedantic setting, it will go and manage app settings and validate the configuration values. What are the configurations value will be there, it will go and verify or configure it. Then Google GenAI. Google GenAI means there is a Gemini SDK which will provide the direct access to the Google Gemini model. So for that we need Google Generative AI. ChromaDB, we already know this is for the vector database. We are storing our embedded data to the ChromaDB. Then LangChain. LangChain is a framework which we are going to use here, right? So it is the core LangChain framework which will be helping us to building the LLM flows over here. Then LangChain community, what it will do is it will help us to support these integration utilities and loaders classes or interfaces. It will provide us to implement our code easily. Then now LangChain Gen AI. So LangChain Gen AI, this will integrate the Google Generative AI with the LangChain models. So after that, request. Why we need request? Because we are going to make the HTTP request and to the external APIs, just like as we used Arjuna in our last video. So same we are going to use it. We are not going to change our project. We are just enhancing it in using the LangChain. So for making the HTTP request for to the external APIs, we need Adjuna API over here. Now PyPDF. PyPDF means we are going to extract the text from the docs file, right? So for the sorry for from the PDF file, for that we need resume PDF file. Then Python docs, so we are reading and extracting that data from the docs file, so we need Python docs. Then Python multipart, it will handle file uploading in the fast API form. Okay, so we are using fast API, so it will handle these file upload. Okay, then PDF plumber, so when we are extracting the text from the PDF, so maybe if PyPDF will not work as expected, then it can use the PDF plumber. Then LangChain Chroma, it will connect ChromaDB with LangChain. Okay, so we are storing our data in the vector DB. So here LangChain Chroma will help us to store that data into the ChromaDB, and LangChain is here helping us to connect with the ChromaDB, and for the retrieval of the data also it will help us. Now, so high level, what is before LangChain? So before LangChain, we'll have our resume, and from that resume we were extracting our text, and when our text got extracted, after that we are going to generate the embedding. When we'll be generating embedding, we'll have Google SDK. So here we'll just have Google SDK. LangChain is not in picture at all. So we'll be just directly using the Google SDK. In place of Google SDK, if we want to use some another embedding model, we have to change this Google SDK, and we need to use OpenAI or some other embedding model which we want to use it over here. So after Google SDK, we'll be querying the ChromaDB, and from the ChromaDB we are getting the data. Now when we'll retrieve the job from the ChromaDB, so we'll be creating a prompt to call LLM. So LLM will go and perform the operations and we'll get the response. So for that we were using the F string, and after that we'll go for the Gemini SDK for the for the LLM, and now it will load the JSON and we'll get the responses. This is before LangChain. Now we are in the place where we are going to implement the LangChain. So what will be the difference from without LangChain and with LangChain? Okay, so we'll have our resume and we are going to extract that text. Is still we are doing this process, but in place of generating embedding, we are going to use the Google Generative AI embedding. This is the LangChain method which we are going to use it here for generating the embedding. Then LangChain Chroma. So before we will be directing querying to the ChromaDB, but here we are going to use the LangChain Chroma, and then retriever. This will retrieve the information. Then we'll, in place of using F string, we are going to use the chat prompt template. So now we are not going to write with that in the string format. We are going to use the template model. Then it will go and chat Google Generative AI. It will go and call the LLM models over here, and then after that JSON output parser. This is again from the LangChain, which will be using, in place of manually doing it, we are using JSON output parser, and we'll get the response in the JSON format. So here we are going to do the JSON loads, but now it got changed. We are using the JSON output parser. We'll move to the VS Code and we'll see. Now we are going to modify our code changes, and we'll go one by one. We'll go step by step, and we are not going to write everything from the scratch, but wherever we can use the LangChain, we are going to modify that particular files over here. So first we'll go to the LLM service file. So if we'll go and see for the previous LLM file, let me just reopen it so we can compare it. This is before LangChain. We'll have the LLM service file. Now after LangChain, this is our LLM service file. So we'll see one by one what is the difference now. So before, we'll have resume and our prompt will be there. Then we'll call the Google Gemini SDK, and then it will go for the Gemini and we'll get the responses. So in our new flow, what will happen is we'll have resume and we'll have our prompt as well, but now we are going to use the LangChain in place of Google Gemini SDK, and we'll get the we'll get the response from the Google itself, Google Gemini itself, but we are making the use of LangChain over here. Okay, so here we are not changing our model, but we are just changing our way of communication. Before directly we are going for the Gemini, now we are introducing a concept of LangChain in between. So we are not creating client manually. LangChain is providing an LLM object to us. Okay, so if we'll see here, we'll have chat Google generative AI. We are using this LangChain in place of generative AI. We are using the LangChain Google generative AI. So we provided our model name, Google API key, which key will be getting it from the .env file, and we set it over here the temperature. So chat Google generative AI, this already aware about the communication with the Gemini. Okay, so it already implemented that code. This is a behind backend things. It is already implemented and it has their own functionalities over here. If we'll see chat Google generative AI, then it has Gemini 3.5 flash. So other models it already have internally. So it is mentioned, right, environment variable, what data it has to fetch, everything is mentioned over here. So this is the this already know how to communicate with the Geminis. Now chat Google generative AI, this is a LangChain integration class where we can connect our application with the Google Gemini model or any other models, and it will allow us to send the prompt to the Gemini and will receive the response in AI generated responses. So this is a integration which is already in the LangChain and we are just going to use it. So in place of Google Gemini, we can use any model over here and we do not need to make many changes if we are going to change our model. Okay, then temperature means this will be a low randomness because we mentioned that temperature as 0. This means our output will be more deterministic and stable. Okay, so if we'll see in the previous one, first we created a client and then after the prompt, I think, yes. So here we are calling the model which is Gemini 2.5 flash model and we are providing the content, and after that we are just stripping our JSON response which will be getting from the model. We are trying to make it as JSON format, in a proper format. If there is any extra words, we are going to strip it over here, but in this case we do not need it. So in place of that we are going to use the JSON output parser. Now before, what we were doing is we are connecting each component manually, and now we are going to use a chain over here. So if we'll see here we'll have resume prompt, that is different. Okay, we are be sending prompt over here, and after that if we'll see LLM, and we are going to call this LLM model and we'll have prompt, then we are calling the LLM model, and at the end we are going to parse that data and we are stripping it over here. But now we are make it as a chain. So now we are not doing it manually, we are not writing it separately, we are making it a chain and automatically it will call it. Okay, so resume chain means we are going to provide a resume prompt. This is the resume prompt and we are building this final prompt here, and we'll send that final prompt to the LLM model, and parser will go and convert that response to the structured format. And this means this is a part of LangChain expression language, and this is connecting the components in the chain. So it means it will pass the answer from the one step to another. What are the information will be getting from resume prompt, it will go and share with the LLM. What will be the response will be getting from the LLM, it will go to the parser. And where is resume prompt? Because before we have this prompt over here in the same file, but now we make it that in a separate file. We'll see that where our prompt is exist. Okay, so now This is the same method which we had earlier as well. If we'll see here, this is the analyze resume with LLM. And now we'll have text and match the job list here. And now we are going to invoke, means it will call our pipeline. Here pipeline means this is the pipeline we created, right? So it will call this pipeline, and this will file create our reusable LangChain pipeline for this our resume analysis project. And the most important improvement here is the prompt creation. So LLM invocation, output parsing from this, and now we are combining into a one LCL chain. LCL just mentioned it, LangChain expression language. So we are making it is in a LCL chain, and we are not doing anything here. We are not making it manually. LangChain is internally taking care of it. Okay, this makes our code more modular, reusable, maintainable, and reliable. Okay, so this is compared to the previous manual implementation. Now we'll go to the another one. So this is about the LLM service. Let me open it. Okay, this is for LLM service. Now we'll go to the embedding service, and let me just reopen the existing embedding one. Yeah, here we go. So now we are using the Google Generative AI embedding method over here. Before, what had is we are just calling embed content directly from the model. Here model client means we are going for the Gemini API key, but now it is going to take care it of internally. If we want to change it, we just need to change the model name and their API keys. We are not going to maintain and change it everywhere. Now this is the model and this is a Google API key, we are using it over here. Okay, so the previous one, it was calling the Gemini embedding API directly, right? If you'll see here, it is calling this directly over here, but now we are using the LangChain wrapper in place of directly calling to the Google Gemini API key. And this one, what it was doing is it is returning a response in the form of object. Okay, and here it is and here it is directly returned response in the format of the vector directly. Okay, so these things are different over here. Now directly we are not calling the Gemini API key, we are using the embedding model of the LangChain or embedding method of the LangChain, and it will call the our Gemini embedding model. So we don't need to take care of it. And before, if we'll see here, it is doing the embedding 0 dot values, so it will require the manual intervention for extracting these values. But LangChain will, we are not mentioning it over here, we are just directly passing our text, and it will go and take care of it, and it will handle this part externally. Okay, internally. Now we'll move to the another file, that is vector store. Okay, let me reopen the vector store for the existing file. So before, it will directly with the chroma collection. If we'll see here, we are directly calling this chroma collection, but now if we'll come here, we are doing it using the LangChain chroma wrapper. Directly we are not doing it here, we are using the LangChain chroma wrapper, and we'll have client, this is our chroma db, then we are mentioning collection name and embedding model. So if we'll see this embedding model, we are going to use it from the embedding service class. Okay, and if we'll see in this one, okay, we are directly writing that chroma collection. Here we are wrapping that data to the with the help of LangChain, and here everything is the manual collection. Okay, manually we are going to collect that data, but here directly we are using the LangChain. Okay, so here what we are doing is, here that embedding part we are taking as a separate part, but now in this case embedding model is already inside that one, and it will take care of that vector store. We don't need to take care of it. If we'll go for the, then another change we have to make it that is in the retriever.py file. So in the retriever.py file, here we were making all the embedding manually. So we have generate embedding query, but here we are not doing it. We are just invoking. We are just invoking the method. We are not doing any embedding part done here, because we already saw in the vector store we did this, we used this embedding model and we were doing the embedding, so we don't need it. And now we are going to invoke our query, but before it was like we are querying it, we are mentioning query embedding and a number of results. Now we don't need to do it, we just need to mention our query and LangChain will take care of it. We don't need to make any changes over here. And this is the metadata collection, and other things are same, but how we are going to generate the embedding and we are going to invoke that query, that is based on the LangChain. Now we are not using the manual methods over here. Now we'll go move to the next file. Okay, so now we'll have this prompt, resume prompt. So before we were using the string f. If we, I'll just open, give me just 1 minute. There, here we go. Using that logic in the service class, we moved it to the separate file directly, and in place of using the python f string, we are using the chat prompt template. And here we are going, here this is a matched jobs. Okay, so before what we were doing is we are just manually taking that matched jobs, but now LangChain internally it will figure it out these matched job, and what are the text is there, this is same. But if we'll see here, this we are not going to take care of it, how we are getting the match job. Internally it will, this prompt template will take care of it, how it want to instruct it. And this is the main change in the prompt. We are not using the string now, in place of that we are just using a template. So these things we are changed, and now we are using the LangChain over here. I'll just show it high level that workflow, but there are not a major changes in our flow, that just we modified few things for implementing the LangChain in our project. So this is the post endpoint. Someone will hit our resume analysis post endpoint and it will go for the process resume. This file as an input, it will take it and it will go to the resume service, and from resume service it will go from the extract text from the file. So we'll go and extract that data from the file. If it is a PDF, we'll extract that PDF file. Then if it will be a docs, we'll be extracting that docs file. And after that we are going to retrieve the context, and we are going to retrieve that context from the ChromaDB. And now here we are invoking the query. In place of manually, we are using here LangChain will go and query our query, and after that we'll get the response in the result section. And this is the document. We are just creating this metadata and we are making it in a our required format, and it will just printing some jobs and it will return the matched job. So now we will have the RAG result with us, and after that RAG result we are going to analyze our resume using the LLM. So here this will invoke our chain, and this will first it will go for the resume prompt preparation, and this is here. So it will just get the template of the prompt and what are the matched jobs, and if we'll see here, we'll passing the matched jobs, right, and text. So everything will be here, and it will come and it will have a prompt now, and it will call the LLM model. And when it will be calling LLM, that is Gemini 2.5 flash, and temperature is 0, it will call the LLM, and after that it will parse that data into the JSON format, and now we'll have JSON output, and it will send back the result. So we analyzed our resume, and now we'll have the matched jobs over here. And if you are removing your ChromaDB, just remember, so you have to run, that is python -m app rag ingest. So you have to ingest your data to the ChromaDB. Okay, we'll go back to our IDE and we'll see how we can execute and what is the output now. Is there any difference from the output or not? Now we will hit our endpoint and we'll see what the data we are getting it over here. Is it similar kind of data, or is there any differences we got it over here? Okay, so now we'll go and hit our endpoint. So we hit this endpoint and now we are going to try it out. We'll choose the file. We are going to choose a resume file and we are going to execute it. It will take some time. We'll come back to the IDE and we'll see what are the data we are getting it over here. Okay, so first it is extracting that resume, and after extracting that resume, it when it is successful, it went to the second step. That was, it will go and match the data from the ChromaDB, and it is retrieved all the matching jobs there. And what are the matched job is there, that data is collected, and after that it is calling the Gemini. When it is calling Gemini, Gemini will do the analysis, and at the end analysis is completed, when the LLM will get the response to us. Now we'll see the response. Okay, so this is success, overall education, skills, experience, education, everything is there, and eligible roles, we can see it over there. Then a structured resume details, experience, education, how many matched jobs are there, everything, what are the existing response we are getting. Similar way we are getting the response over here, but just a difference here is we are using the LangChain framework in place of doing everything manually from our end. So we need to run the UV command, and after that we are going to hit our endpoint and we'll see the response. In the next lecture, we'll learn about the Lang graph. Until next time, keep learning, keep building, and keep growing. We'll see you in the next lecture. Thank you.